Okay, let's take a look at this relatively simple solution stoichiometry problem. The problem reads, Charlie Chemist decides to mix 75 milliliters of 1.2 molar sodium chloride with an excess, that means more than enough, of lead nitrate solution. Okay, then we're given our chemical equation. And the first step of all solutions stoichiometry problems, really of all stoichiometry problems in general, is to balance your chemical equation. So to balance this, I'm going to have to add a couple of coefficients here, and that's really important. Now that I've got a balanced chemical reaction, I can begin solving my problem here. The first step is to find moles of NaCl, and I'm given the molarity equation just as a reminder right here. Some students like to put that molarity equation in a nice little triangle. So it's molarity is equal to moles divided by liters. In this case, the only information I am given about sodium chloride is milliliters, which I can eventually switch to liters and plug in here, and then the molarity, which I can plug in here. So my unknown is going to be moles. And if you cover over the unknown variable here, it'll tell you how to solve it. You just multiply your molarity times your liters. So let me go ahead and plug this in so you guys can see what that looks like. For my molarity, I had 1.2. My moles is unknown in my numerator. And then watch what I'm going to do here. Instead of using 75 milliliters, you have to convert to liters. And this is really important because your molarity equation specifically requires liters. You cannot use 75. You have to move the decimal point 3 spaces to the left and use 0.075. To solve this, again, all you're going to do is multiply your molarity times your volume. So multiply 1.2 times 0.075. And for your answer, you should end up with 0.09 moles NaCl. Beautiful. Okay, answer that question. The next question says, what mass, that means I need to end in grams, of lead chloride will be produced? Well, right now I'm given moles of sodium chloride. I can do a bridge step to get moles of lead chloride and then do one last conversion to get grams of lead chloride. Oh my. Okay, let's see how this is going to look here. I'm going to start with 0.09 moles of NaCl. Do my first conversion. I'm going to look at my mole ratios here. Because I have moles of NaCl up top in my numerator, I know I'm going to have moles of NaCl drop down in my denominator to cancel. So let me just get my units set up here. That way I know they'll cancel. And the problem wants grams of lead chloride. I can't put grams of lead chloride up here in my numerator just yet, but I can very easily get to moles of lead chloride. I can see moles right there in my balanced chemical equation. So where do I go to get my mole ratios? That is one of my favorite questions in chemistry. You must look at your coefficients in your balanced chemical equation. So in front of lead chloride, I see a 1, and in front of sodium chloride, I see a 2. So that's what I'm going to use here. The 1 goes up top, the 2 goes down below. And I'm not quite done. If I were to solve this, my answer would be in moles of lead chloride, and that's not what the problem's asking me for. It's asking for mass of lead chloride. So I got one more conversion to do. If I have moles of lead chloride up top in my numerator, I know I'm going to have moles of lead chloride down below in my denominator. That way they'll cancel out. So that's what I'm going to put down here. And then I want to end with grams of lead chloride. This is just a simple mole to gram conversion. You guys have done this hundreds of times in chemistry, and it's 1 mole of lead chloride is equal to 277 grams. Where did I get that 277? That's my favorite question. You used your periodic table. I added up 1 lead plus 2 chlorine. That's the molar mass that I got off the periodic table. Okay. My units are going to cancel. Moles of sodium chloride cancel. Moles of lead chloride cancels. I am left with grams of lead chloride, which is what I want. How do I solve this bad boy? You can multiply everything up top together. So punch in your calculator 0.09 times 1 times 277, and then divide by everything in the denominator. Hit divide by 2, hit divide by 1. Some students like to go in kind of a zigzag fashion and then multiply and divide as they go. I'll show you that way too. Start by punching in your calculator 0.09, divide by 2, multiply by 1, divide by 1, and then multiply by 277. So you can solve this either way. Basically, if it's up top, you multiply it together, and if it's down below, you divide by it. So once you do all those numbers and crunch through them, you should end up with 12.47, and my unit is grams of lead chloride. This was a relatively simple solution stoichiometry problem. We can get more complicated, and they will, believe me, and ask you questions like which was your limiting reactant, different things like that. But for right now, this is just a short little intro. This has been a Rodriguez original production. I hope you enjoyed. Go back and study your notes, look at more examples. Good luck.